Well, before diving into instantaneous velocity, what exactly is velocity? Many people think speed and velocity are synonyms. Well, they're not. Speed is just a number with a unit, such as 32 meters per second. Velocity is speed with direction, such as 32 meters per second to the right. Now let's go over average velocity. Say you're going from point A to point B, where the distance between these 2 points is 300 meters. You start running as fast as you possibly can from point A for the first few seconds, but then you slow down to catch your breath. After catching your breath, you run again. So you reach point B in 500 seconds. Distance 300 meters. Time 500 seconds. Average velocity is the distance over time plus the direction. So no matter how many times you slow down in the middle, as long as you didn't start randomly flying like Superman into space, your average velocity does not differ. So the average velocity of this would just be 300 over 500 meters per second, or 3/5 meters per second to the right. Now, how do you write to the right? Well, positive 3/5 meters per second is equal to 3/5 meters per second to the right. If you were to go 3/5 meters per second to the left, instead of a positive symbol, you put a negative symbol. So negative 3/5 meters per second is 3/5 meters per second to the left. Now on to instantaneous velocity. Instantaneous velocity focuses on the velocity at a specific time. Now that makes no sense at all. How does a specific point in time make sense? You could have a very small time interval, say 0.000001 nanoseconds. That's very, very small. But the time interval compared to a specific point in time is still too big. It's like taking a line and then shortening it until it becomes a point. But the problem is it never does. A line is a two-dimensional figure, while a dot is a one-dimensional figure. So that makes no sense. Well, there was this dude, who's now extremely dead, who came up with a solution to this problem. He invented a completely different type of mathematics. So you might know him as Isaac Newton, the guy who invented calculus. Let's look back at how we solve derivatives. Say we have a coordinate plane right here, and you have a curve that goes like this. You have a point right here on this exponential function, but you can't find the slope of that point. It's one point. How do you find the slope of a line? You take 2 points and you do change in y over change in x. Now that means you have 2 coordinate points, but when you try to find the slope of a point, you only have 1 point. Well, how do we do derivatives? It's impossible to find the slope of a specific point, so we made the interval extremely small, to the point where it's just a point. That pun was intentional. This idea can be strange at first, but you'll start to get used to it. So let's write a general rule. The average velocity, AV, is calculated as x over t, where x is the distance, while t is the time. Now, we're working with infinitely small numbers, so we just take the derivative, and we end up with dx over dt. The infinitely small change in distance over the infinitely small change in time.